So this video is going to focus on the first topic in our atom unit, which are the particles that make up the atom. Specifically, we're going to review what you should expect to know about protons, neutrons, and electrons. That both protons and neutrons are found in the nucleus, while the electrons are found outside of it in generalized regions called orbitals. That protons are positively charged, that neutrons do not have a charge, they are neutral, and that electrons are negatively charged. That if we look at the relative masses, protons and neutrons are very similar in terms of mass. The picture at the bottom also shows that. They're still really, really tiny, but they are comparable in terms of their size, and they are much, much larger than that of an electron. An electron is about 1/1000th the size of a proton or neutron. Protons help us identify every element. On the periodic table, there is atomic numbers, and those atomic numbers are determined by how many protons are found in that element's atoms or ions. Neutrons help us determine what also is in the nucleus of that atom. They help us determine isotopes. Every element's isotope will have the same number of protons as any other of its element's isotopes, but it will have a different number of neutrons. And mass number allows us to look at both protons and neutrons. So your isotopes will be unique for a given element because they will have different mass numbers. And then electrons help us distinguish between neutral atoms with a charge of 0 because they have equal numbers of protons and electrons, and ions, which will have a different number of electrons than they have protons. Specifically, because these are some terms people have a little bit of trouble with sometimes, we're going to focus on atoms, ions, and isotopes. Atoms, again, are neutral, and you've got a couple pictures of neutral atoms here, these two right here, where they have the same number of protons and electrons, whereas ions do not have an equal number of protons and electrons. We see in this +1 sodium ion how there's one less electron, where in this -1 chlorine ion there is one more electron. Remember that the protons can't change or else your element changes, but the electrons can be lost or gained to form ions. And the terms underneath that, cations and anions, should be reviewed for you. This is a positive ion, so sodium would be called a cation, while as chlorine would be a negative ion, so it would be called an anion. I talked a little bit about isotopes, but because that's a concept kids have a little bit of trouble with, I wanted to focus on it a little bit more. If you look here at these two pictures where the nuclei of these two isotopes are blown up, you can see that each one has 6 bluish circles with a positive sign indicating the 6 positive protons that make it be carbon, while the number after it, which is representing its mass number, is larger in the one to the right because there are more purple circles. And that's because this one's slightly heavier. It has 8 of these purple circles because it has 8 neutrons, while carbon-12 only has 6 of them. So these would be considered isotopes of one another because they are the same element, but this atom's nucleus is a little bit larger than this one because of the additional 2 neutrons. So isotopes are, pairs of them will only be found for a given element, and they will only be found if that atom's nucleuses are different in terms of their neutrons. The next thing we're going to talk about is a symbol that tends to be used to denote the different features that we just talked about in terms of protons, neutrons, and electrons. The A term, the one found in the top left-hand corner, I'm not going to quiz you on A, I just wanted you to see that kind of as a place where you would represent your mass number that is found in the top left corner, and that is the sum of your protons and neutrons. So in these two examples over here, 24 is representing the protons and neutrons found in this magnesium element, while this one here has 26 protons and neutrons, so it has a different number of neutrons than it has protons when compared to this one. So these two would be considered isotopes of each other because of the different mass numbers, and they are still representing the same element. The Z underneath is giving you the number of protons. Again, you can get that from the periodic table, and if you go and look on your periodic table, you will see that magnesium has a 12 between its symbol and its name. So to get the neutrons, I can take the difference between the top number and the bottom number, my mass number and my atomic number, and I can determine how many neutrons are present for that particular atom or ion's nucleus. And then finally, the top right-hand corner represents the charge. If you are a neutral atom, your charge would be 0. So you could have a 0 next to this magnesium symbol, but you don't have to. If it's understood to be 0, you can leave it blank. However, this one does have a charge, which means that if it's +2, I have 2 more of my positive particles than I have of my negative ones. And so my protons are going to be 2 more. If I have 12 to begin with, I would have 10 electrons. Yes, I need to plug in my battery. So we're going to do some examples with these atom structures to hopefully help make a little bit more sense of these terms, and they'll go along very closely with your worksheet 1, 2, and 3 in the atom unit. So the first question I ask you is how many protons and electrons are in an oxygen atom. So if you go and look on your periodic table, you're going to see this up there for oxygen. And oxygen has that 8 between the O and oxygen, which is telling us it has 8 protons, as that is its atomic number. I also told you that oxygen is an atom, and by telling you that oxygen is an atom, I'm telling you the protons and electrons must be equal. So if it has 8 protons, it has to have 8 electrons. And that's all you would need to answer that question. You need the element on the periodic table, and to recognize that as it is an atom, the protons and electrons must be equal. So if I want you to find the protons and electrons in an ion, you would still have to go look at the periodic table to find out about your protons. Barium on your periodic table has a 56 between its name and symbol, so therefore it has 56 protons. We have an ion with a charge of +2. If you are an ion, I have to give you a charge to look at. That +2 is telling me that it has 2 more protons than it has electrons. Since the proton number can't change, the electrons are going to have to go down from 56 to 54. And then again, remember that in the third example, how many protons and neutrons are in silicon-28. Again, the 14 between Si and silicon gives me my protons. The number 28 is not a negative connecting silicon to 28. It is a dash, and that is indicating how many protons and neutrons are present in that isotope of silicon. Because it has 28 protons and neutrons, and I already know how many protons it has, the difference between those will tell me how many neutrons it has. So if I add the 14 protons and the 14 neutrons together, I should get the mass number of 28. That mass number could have been larger or smaller, and if it was, the neutron number would change correspondingly. Our next 3 examples, I ask you to write the chemical symbol for the element with 34 protons and 36 electrons. We usually start with protons or the element. This time we have protons, so we would have to go look on our periodic table to find out what has 34 protons, and that is selenium, so the symbol would be Se. With the information given, I can also tell you the charge. There are 2 more electrons than protons, which means that I would need to have a negative charge this time since the electrons are negatively charged, and it would have a -2 charge. The last 2 examples on this particular slide are inverses basically of one another, or mirror images. I'm going to ask you to draw that symbol for the last one, and I'm going to have you break it apart for the one that we're going over right now. As a reminder, remember that that bottom number next to silver is your atomic number, which is your protons. You could also get that from finding silver on your periodic table. The top number is representing your mass number, your protons and your neutrons. So to get the neutrons, I would need to subtract the protons away from 108. And when I do that, I get that there are 61 neutrons. And then I can use the charge to help me determine how many electrons there are. There's 1 more proton than there are electrons. Since I know how many protons I have, I can have my electrons go down by 1 from 47 to 46. And then again, on the last example on this slide, we're going to write one of those symbols. So we would need to go look on our periodic table to figure out what element has 52 protons. Sorry, the whole thing's not showing up, but if you look on your table, I think you're going to find that that is tellurium. And then we want the bottom number to represent our protons, which would be our atomic number. So 52 would go to the bottom left. Our mass number would be the protons and neutrons added together, which would be 128. I don't think the charge is going to show up. I'm sorry. It'll be on the PowerPoint slide if you want to go look at that. It's where my screen cuts off. But the charge would be the difference between my protons and electrons. I have 2 more electrons, so I need to have a -2 charge. And the last part of this video, we're going to fill in a table just so you can kind of see how you would answer questions like this. A student in one of my classes asked what would be the first thing you should start with, and I said you want to start with your protons. So we're going to look for fluorine on our periodic table, and I think if you go find fluorine, you're going to find out it has 9 protons. Because I told you it's an atom, that tells you it has 9 electrons. And the difference between protons and electrons gives me my charge of 0. So if I wanted to draw a complete chemical symbol, I would put the F in the middle, representing my element. The bottom left-hand corner would be my protons, my atomic number of 9. The top left-hand corner would be my protons and neutrons, which would give me 19. And then my charge would be 0. The isotope name is going to be the element's name and then a dash and then the mass number. So for this particular isotope, it would be fluorine 19. In our second example, we would need to go find oxygen on our periodic table. And if we go find oxygen, we're going to see it has an atomic number of 8, which means it has 8 protons. It's an ion this time, so we're going to have to use our charge to help us figure out how many electrons this ion has. The charge is -2, which means I need to have more electrons, since that's the only way I can be negatively charged. And I need to have more by 2. So if I have 8 protons, I would need 10 electrons. The difference again between your protons and electrons will always give you your charge, and 8 minus 10 is -2. The symbol O will need to go in the middle of my complete chemical symbol. The bottom left-hand number will give me my protons, which would be 8, the atomic number. The top left-hand number would be my mass number, my protons and neutrons, which would be 17. And then my charge would be -2, and I would write that this time. And the one above it, you could have put a 0 again for fluorine, but you do not have to if it's understood to be a neutral atom. To name the isotope, I would write oxygen, dash, and then the mass number, which would be 17. In my third example, I didn't give you protons or the element's name, but we're still going to start with finding protons first. We can do this because I gave you the electrons and I told you that this particle had a charge. The charge is +1, and that means I need to have more protons by 1 than my electrons, which means I would need 37 electrons. And that would give me, if I go look on my periodic table, that it is rubidium, and rubidium would be a charged particle, so it is an ion. Rb would need to go in the center of my complete chemical symbol. Again, atomic number, which is my protons, goes in the bottom left, 37. Mass number, which is my protons and neutrons, goes in the top left, 84. And my charge +1 would go in the top right. To name this, I would give it the full name of the element, rubidium, dash, and the mass number of 84. In my final example, I gave you silver-108. That's telling me that silver would be my element, and if I look at the very end, I see that it has a charge of 0. So this has to be an atom of silver. If I look on my periodic table, I can find silver's atomic number, which gives me my protons of 47. Neutrons can be determined by taking that 108, which is my protons and neutrons, my mass number, and subtracting it from 47, which would give me 61. Sorry, I went out of order. And because it's neutral, it would have the same number of protons and electrons. So to write my final symbol, Ag goes in the middle. 47, the protons, my atomic number, goes in the bottom left. The 108, which is my protons plus neutrons, goes in the top left. And I don't have to write anything for the charge. If you did wish to, you would need to write a 0. So that's the end of the first video in our atom unit, and at this point you should be able to do your first 3 worksheets.